How are you? I hope you're all well and doing well and good. Okay, so this is the table I gave you last time, fill in the blanks. And I think you did it already, some of you. And next slide is the answer for it. Okay, so these are the answers, the final answers for them, if you want to check your work. If you have any problem with anyone, how to work it out, just let me know and I can explain it to you. Okay, so today what we are going to do is integration by substitution. And integration by substitution is really a really very powerful method. If you know how to do the integration, it will be useful for you in the future at the university. All right. So as you can see here, what we have is we have a function inside a function. So as you can see here, we have the function x squared minus 3 inside another function which is to the power 4. Okay? So therefore, to do the integration by substitution, we need to do something, use the substitution, and we need to replace actually what's inside the bracket or what's inside the other function. So basically we need to replace what's inside with something else, and usually we use a letter, which is the letter U, to substitute that. So, before I start also, integration by substitution, it's usually we use it if we have two functions inside each other, or when you have a square root sometimes. It's some complicated integrations that you can't deal with it with the other method you learned already. Okay, so in this case, what we're going to do, we will refer to the function, which is the inside brackets, which is inside the function to the power 4, by the letter u. So I would say let u equals x squared minus 3, okay? And then so we need to find du. So if I make this u, that's going to be x u to the power 4 dx. And this is a problem here at the moment because we have dx, because we can't, in that case, we can't integrate u to the power 4 if we have dx. We need this dx to be changed into du. How to change dx into du? Basically, to do this, we need to differentiate the u here. Okay, so if I have u equals x squared minus 3, then du over dx will be, because u it's a function of x, u is a function of x. Therefore, when we differentiate, it's going to be du over dx, which is, in this case, it's going to be 2x minus, differentiate just 2x, there's no. Okay. So, right, so so that's du over dx equals dx, 2x, sorry. Now, we need to find dx, in terms of u, so we can replace it. So in that case, we can multiply both sides by dx, or rearrange it, whatever you know how to understand this. So there's going to be du equals 2x dx. I want dx, remember. So dx equals dx equals du over 2x, right? Dx equals du over tx. So now what I will do, I will use this, yeah, we will use this and replace it by this, okay? So I will have x u to the power 4, and instead of this dx, I will put du over 2x. Okay, and now I can cancel these the x's together. So this x can be cancelled with this x because it's multiplication, and therefore also what I can do, just instead of I keep saying this equals, yeah, I can say refer to this integration. Let's say let I equals this integration x squared minus 3 to the power 4 dx. So instead of keep saying this integral, I would say therefore I equals, which is the question from the beginning, equals what now? It's the integral of u to the power 4, yeah, du. So u to the power 4 divided 2 du, okay? And this will be just a straightforward now. It is, what's the integration of u to the power 4? We add 1 to the power and divide by the new power. So this is going to be u to the power 5 over u over 10, yeah, because 2 times 5, which is 10, okay, and plus c. So this is going to be u to the power 5 over 10 plus c. So now I finished, which is now as you can see, it's just a straightforward, simple. That's how powerful is the substitution method. It's change a question very complicated into very easy way. Now the last step you should do is go back, substitute u by the value we assumed, like substitute u by the x things, yeah, like this. So this now going to be I equals, instead of u to the power 5, I will write it as x squared minus 3 to the power 5 and divided by 10 plus c, and that's it. Okay, right. Next question now here. I have this, actually this needs to be x cubed. Yeah, it's x cubed root 1 minus x squared dx. Okay, so again, let's say I equals, yeah, make this I equals this term, right? So what we have here, we have a function again, which is 1 minus x squared inside the other function, which is the square root, right? So what we will do, I'll take the what's inside the root, I'll call it u. Okay, so let u equals 1 minus x squared. Okay, and then as I said earlier, in the integration, if this is going to be x cubed, and then there's going to be u to the power half, this dx, we can't integrate if we have u here and dx here. This needs to be du, yeah? So what we need to do is differentiate the u to find du. So it's important as well to use it as du over dx, not u dash, yeah? Don't do u prime, u dash, because the reason we are doing du over dx to find dx from it. So if you put just u prime, u dash, you will forget about the dx and you can't find dx. Okay, so make sure you find the step as du over dx, which is equals, in this case, is minus 2x. Okay, and a cross multiplication, if you want to say it, then dx is du over minus 2x, du over minus 2x. Okay, so I will use this dx and replace it instead of this, and instead of the 1 minus x squared I will use u. So this now will be so I equals, okay, it's going to be equals to x cubed u to the power half, and instead of dx I will use du over minus 2x. Okay, now I have this x can be cancelled with one of these at the top, so there's going to becomes x squared here, and then this will be equal to the minus at the bottom. It can be at the top, it doesn't matter, there is no difference. So there's going to be like minus x u to the power half du and over 2 here. Okay, this is x squared, sorry. Right, okay. In this case, we still have x in the integration. We shouldn't get any x in the integration when it becomes du. So we need to get rid of the x, basically. So to do that, we can go back to our u here, yeah, because we have u, because u equals 1 minus x squared, then we can find x squared, yeah? Then x squared equals what? 1 minus u. You okay with this? Happy, happy? I hope so. So now I will use this here instead of the x squared. So this becomes now the integration of minus, instead of x squared, I will put 1 minus u, okay, u multiplied by u to the power half and du divided by 2, okay, and this will be, okay, I will just enter the sign in here. Okay, so this will be, what is it? It's going to be minus, well, actually, yeah, we can put the sign and the u to the power half, yeah? The u to the power half will as well multiplied. So the first one is going to be minus 1 plus u. Okay, let me do it first with you, and then I'll show you. Just don't have much space, so maybe need to make my writing smaller. So there's going to be integration of minus 1 plus u, okay, multiplied by u to the power half du over 2, which is equals to, now it's going to be like u squared times minus 1 u to squared times u, right? So this will be equals to minus u to the power half over 2 and plus u to the power 3 over 2, because u to the power half times u to the power 1. Yeah, when we multiply, the power will be added. So 1 plus half is 1.5, yani 3 over 2. So it's u to the power 3 over 2 divided by 2 du. Oops, du. Okay. Now, okay. So now I equals, what is it? Equals, so we will add 1 to the power. So now we will integrate. So it's going to be minus u to the power, I'll change the color actually. Yeah, so minus u to the power 3 over 2 divided by the 3 over 2. And we already have 2 here, yeah? Then plus, again, this one is going to be u to the power 5 over 2 because the 3 over 2 plus 1, يعني 3 over 2 plus 2 over 2, or 3 over 2 here, which is 1.5, plus 1 is 2.5, so that means 5 over 2. I shouldn't explain all these things for you, you should know them anyway. But anyway, yeah, so u to the power 5 over 2 divided by 5 over 2, and that's, as I said, it's already multiplied by 2. I mean, yeah. So now I will cancel these 2's. So we'll end up with equals, and that should be plus c basically, yeah, plus c. Then this is going to be equals to, this is going to be equals to u to the power 3 over 2, so equals minus u to the power 3 over 2 over 3 plus u to the power 5 over 2 over 5, okay, plus c. And this, then now we need to return u back into in terms of x's, yeah. So this is important as well. So change color. So which color? Red. And that will be, that's final one, minus 1 over 3. Instead of u is 1 minus, yeah, see, u here is 1 minus x squared, we said. So instead of u, I will say, okay, that's 1 minus x squared to the power 3 over 2, okay, plus the u to the power 5 over 2. Again, instead of u, we'll put 1 minus x squared to the power 5 over 2. And this is going to be over 5 and plus c. And that's it. Okay, happy? Yes, hopefully. Right, next slide is this. Again, need a little bit change here, the question. It's 1 plus sine x, right? So I'll just write it again. So again, go back, let's say this integral called integral of cosine x, sine x, 1 plus sine x all to the power 3. Again, as you can see, this is a function here, which is, the lovely function is 1 plus sine x, and it's inside another function, which is to the power 3. So we will assume what's inside the bracket as u. You okay? I hope so. Then I'll say, there you go, which color? Blue. So let's say u equals 1 plus sine x, and therefore we need to find dx, so we'll do du over dx. We differentiate u, which is, what's the derivative of the sine? Is cosine, yeah? So du over dx is going to be cosine x, because 1, the derivative of 1 is 0. Right, so du over dx is cosine x, then rearrange, therefore dx will be du over cosine x. Okay, so now I will use all this and substitute in the integration. So I equals, go back to the green here, I equals the integration of cosine x and sine x and then this is going to be, instead of 1 plus sine x, it's going to be u to the power 3. Yeah? So I don't need the bracket here. U to the power 3. And instead of dx, I will use this term instead of the dx. So there's going to be du over cosine x. I hope you're okay so far. And now we can cancel down things, yeah, cosine x, go with cosine x here. And we still have sine x. So we can't leave it sine x because in terms of x, it's a function of x here. So we need to find sine x in terms of u. So what we do, we'll go to our term here, yeah. As you can see, u equals 1 plus sine x, and find what is it? Sine x in terms of u. So therefore sine x equals u minus 1. Okay? Right. So I will substitute this. I use it instead of the sine x here. Right? So the integration is going to be I equals the integration. So look how lovely and easy now. So it's integration of, and instead of the sine x, I will put u minus 1. And then this multiplied by u to the power 3 and du. Is there any x here? No. So now I'll just multiply out the brackets. So there's going to be, let's go back to the green actually. I equals the integration of u to the power 4 minus u to the power 3 du. Yes? Because u to the power 3 times u is u to the power 4 minus u to the power 3 times 1 is u to the power 4. Sorry, u to the power 3. Okay, du. Now we'll integrate. So I equals, so when we integrate, we just add 1 to the power, yeah? Add 1 to the power and divide by the new power. So u to the power 4 plus 1, it's going to be u to the power 5 divided by the new power 5. Minus u to the power 3 plus 1 is u to the power 4. So this is the lovely new power divided by 4. And plus c. What to do now? Come on, what to do? We change u, yeah, replace u by 1 plus sine x. So therefore there's going to be 1 plus sine x. Each u will replace it with 1 plus sine x here. And this to the power 5 divided by 5 minus 1 plus sine x to the power 4 divided by 4 plus the lovely c. And as I said before to you, if you forget about the c, you will lose 1 mark. It doesn't worth to lose 1 mark, so make sure to put that c. And that's it for this question. Lovely. I hope so. So, right. So what I want you to do now is to try the exercises on page 355, which is exercise 9.1, right? Just try as many as you can of them because they're really good questions and it's a variety of them. Okay, right. So, no, that's later. Right. So now I want to work out one of the questions for you, which is I'm going to do question 4C for you. Okay, 4C, this one. Right, so I'll just write it down here. So question 4C. Okay, if I equals the integration of e to the power 2x over 1 plus e to the power x dx. Okay, so in this kind of questions, when you have a fraction, yeah, it's easier and better for you, and you should think about writing it as multiplying two functions. So you should think of writing this function integral as e to the power 2x multiplied by 1 plus e to the power x to the power minus 1, because it was at the denominator, at the bottom of the fraction. Okay, and when you see questions like this, you need to think this way, and also what's at the bottom of the fraction, that will be what will be referred to u. So in this case we will say, okay, let u is 1 plus e to the power x, okay, and therefore du over dx, because u is a function of x, so du over dx is going to be only e to the power x, because the derivative of e to the power x is e to the power x, derivative of 1 is 0. So therefore dx is going to be du over e to the power x. Okay, now I'll substitute these values in the integration. So go back, green, I equals the integration of e to the power 2x divided by u, okay, and now dx is du over e to the power x. Okay, is there anything we can cancel down, get rid of? Yes. So I can get rid of e to the power x here with one of them at the top. Okay, and this is going to be integration of e to the power x over u du. So I still have the e to the power x. I don't need any x in my integration when I put du. So I go back to my function u equals 1 plus e to the power x. Yeah, I go back here. And I find the e to the power x. So from this one, I can say, therefore, e to the power x is u minus 1. Yeah. So I can use it here in my question. So this is going to be, yeah, e to the power x equals u to minus 1, just for you to remember. So this is going to be equals to integration of u minus 1 divided by u du. Okay, so I equals, I'll just carry on, right, this means u over u, integration of u over u minus 1 over u du. Okay, and basically that means 1 minus 1 over u du, and this was going to be, what's the integration of 1? Is u. So when I integrate, when I do the integration, when I integrate the integral thing, I don't need to put the integration sign anymore, all right? So this is going to be u, then minus what is it? Minus ln u, minus ln u. Okay, because integration of 1 over x, that's what you usually know yourself, equals ln x. Okay, so same thing, 1 over u du is ln u, and then plus c. Just put this. This is just for you as a note to remember why, or to know why I did this. Right, so go back, then therefore I equals, right, so now I change all my u's into the origin thing. So u is 1 plus e to the power x, so instead of, I'll write it down here again, ln u plus c, then instead of u is going to be 1 plus e to the power x minus ln 1 plus e to the power x plus c. And again, that's it. I hope you understand.